Hello, everybody. We're going to begin our discussion on heart disease. And I have to, I wasn't going to say it because it's a terrible pun, but I'm going to do it anyway because I don't have to look at your faces while I'm saying it. It breaks my heart that I can't do this in class. I have a wonderful model of the heart that I use to go through the anatomy of the heart and the different chambers and how blood flows through the different chambers. And then I love to just write across the board what's called the pulmonary and the systemic circuit, way blood flows from our heart to our system, the systemic circuit, how our blood flows from the heart to the lungs. But circumstances are such that I cannot do that this semester. Fortunately, Khan Academy has put together some amazing videos that I will ask you to look at. Here are the 5 leading causes of death from 1902, 1950, and 2016-2017. If you notice, in 1902, the leading causes of death were infectious diseases, tuberculosis, pneumonia, and the flu. Well, now we have vaccinations. We know more about hygiene. Germ theory has become more acceptable in most circles. We're no longer dying in large numbers from TB, pneumonia, and influenza. Heart disease and cancer are now the leading causes of death. And with that, let's look at an overview of what we're going to be covering in this topic. We'll look at the cardiovascular system. Cardio means heart, vascular means blood vessels. The systemic and pulmonary circuit is part of the circulatory system. So we'll look at the anatomy of the cardiovascular system and how blood flows from the heart throughout the body. We'll look at major forms of heart disease. We'll talk about the diagnosis and treatment of cardiovascular disorders and risk factors for cardiovascular disease. We'll start with the cardiovascular system. So this is where I would take out my models and I would stand in front of you and start talking. I would get my markers and start writing on the whiteboard, but not this time. This time I'm going to go briefly through some slides with the information, and then I have a slide that will say stop and watch. And what I ask you to do is go online, depending on what campus you're on, and view the different videos, because Khan Academy folks do an excellent job on the first 2 topics. The third video is another Discovery Channel video, The Body Story, the same people who put out the video we watched when we were discussing infection and immunity. So please watch these. They're really good. I think the heart attack video that you see, there are a couple errors, and one of them, the narrator says that cholesterol in food will build up in your blood. We know that's not true. Because I have this picture, I do want to briefly go over with you the anatomy of the heart, but I will let you take your time to go through the videos that Khan Academy puts out. This is a model of the heart. Imagine that I am facing you and showing you the heart, so the right atrium and the right ventricle are on the left side of the slide. The left atrium and the left ventricle are on the right side of the slide. Please try to keep this mirror image in mind, because that's how all the slides and all of the videos will show you the heart. We have deoxygenated blood, blood that has come from the body. It's given up its oxygen and it contains carbon dioxide. It enters the right atrium of the heart. It goes across what's called the right AV valve into the right ventricle of the heart. Then it moves up through the semilunar valve into the pulmonary artery. And the pulmonary artery then branches off to the right and left lung. The blood will flow from the pulmonary artery to the lungs, where it will give up its CO2 and you will exhale it. And then as you inhale, you will inhale oxygen, and oxygen then turns the blood red. So this oxygenated blood that has moved away from the heart through the pulmonary artery will start making its journey back to the heart through the pulmonary vein. The pulmonary vein will then enter the left atrium. Oxygenated blood enters the left atrium, crosses over the left AV valve into the left ventricle, goes up through the semilunar valve, crossing the huge artery called the aorta, which then splits off and moves to the upper and lower parts of the body. We have oxygenated blood moving throughout the entire system, the upper parts of the body, the shoulders, the neck, the brain, the lower parts of the body, your abdominal organs, the legs, the feet. So we have blood flowing to the upper and lower parts of the body. And that blood travels from the arteries into tiny, tiny diameter blood vessels called capillaries. It's at the level of the capillary that the oxygen will diffuse out into the blood vessels, surrounding blood vessels. It will then pick up carbon dioxide, which now makes the blood deoxygenated. And that deoxygenated blood will make its way back to the heart. Blood from the lower parts of the body will enter the heart through what's called the inferior vena cava. Deoxygenated blood from the upper parts of the body will enter the heart through the superior vena cava. And these circuits are operating at the same time. It's incredible. We have oxygenated blood flowing throughout the body. We have deoxygenated blood flowing throughout the body at the same time. Every time your heart beats, these circuits are functioning simultaneously. This is why I love the heart. As I said, forgive me or don't. It breaks my heart that I can't go through this with you in person. But Khan Academy video, Meet the Heart, will explain this and everything I just ran through in more detail. What I do want you to notice on this particular model of the heart are the blood vessels on the outside of the heart. These are called the coronary blood vessels. They supply and drain the heart itself. The heart has its own independent blood source. When a person has surgery to deal with clogged arteries, bypass surgery, they're not opening the heart. What they're doing is working on these coronary blood vessels on the outside of the heart. It's amazing. Please stop and watch. It's about a 10-minute video on meeting the heart. And then I'll meet you back here. That was our first video from Khan Academy. The second video is going to cover the systemic and the pulmonary circuit. I'll just briefly introduce those. Systemic circuit is what transports blood from the heart to the system. We're looking at the red arrows. They're coming from the left ventricle. This is oxygenated blood that's leaving the left ventricle, moving through the semilunar valve and splitting off and going to the upper and lower parts of the body. It goes from the artery. This aorta is a major artery, branches off into tinier and tinier diameter vessels, ultimately getting to capillary beds in the upper and lower parts of the body. This is where the oxygen will diffuse out of the blood and into the surrounding tissues and into the organs. Oxygen moves out of the bloodstream into the tissues, and CO2, or carbon dioxide, then moves from the tissues back into the bloodstream. We now have deoxygenated blood, which is on the left part of this diagram. It's what's on the left side, the deoxygenated blood, that then starts making its way back to the heart through the veins. Arteries move away from the heart, veins move back to the heart. So these veins carrying deoxygenated blood move through the blood vessels, merging into larger and larger diameter blood vessels until you have the inferior vena cava with deoxygenated blood entering the right atrium and deoxygenated blood moving through the superior vena cava from the upper parts of the body entering the right atrium. And that's the systemic circuit. The pulmonary circuit refers to the blood that's moving to the lungs. We would have deoxygenated blood moving to the lungs because that's where it picks up oxygen. The pulmonary circuit starts in the right atrium with blood that's coming from the system or the systemic circuit. It enters the right atrium, crosses over the right AB valve into the right ventricle, then through the semilunar valve, moves up, splits into the left and right pulmonary arteries, breaking into smaller and smaller blood vessels until ultimately these tiniest diameter blood vessels called capillaries enter the lungs. It's at the level of the capillaries in the lungs that the CO2, that's what makes the blood deoxygenated blood, diffuses out of the bloodstream into the alveoli, which we'll look at in a second. You exhale that CO2, the oxygen that you inhale moves from the lungs back into the bloodstream and oxygenates the blood, which then starts moving back towards the heart, entering the left atrium. That ends the pulmonary circuit. Pulmonary circuit involves blood going to the lungs. The systemic circuit involves blood going to the system, to the rest of the body. Now watch the Khan Academy video on 2 circulations in the body. A little more information on pulmonary circuit. We've seen this diagram before. These are alveoli. They're tiny grape-like sacs at the end of the bronchioles in the lungs. On the left, we have one that's been kind of cut in half, so you can see that's a clean one. That person's not smoking. The one on the right section where the blood meets up with the lungs. These are capillary blood vessels. These are tiny, tiny diameter blood vessels. The blue ones represent deoxygenated blood, in which the CO2 will diffuse from the capillaries into those grape-like sacs known as alveoli, and then you will exhale that CO2. The red capillaries represent oxygenated blood. As you inhale through those alveoli, the oxygen diffuses across the membrane into the capillaries, thereby oxygenating the blood, and the oxygenated blood will move throughout the rest of the body. That's the circulatory system. It's a system or network of blood vessels that carries blood throughout the body. Pulmonary circuit, arteries carry deoxygenated blood away from the heart. Veins carry oxygenated blood back to the heart. In the systemic circuit, the superior and inferior vena cava carry deoxygenated blood to the heart. The aorta, the huge artery that leaves the heart, carries oxygenated blood to the body. If you want to look at a rap song, who knew that you could put the pulmonary and systemic circuit into a rap? You can look at this link that I have posted online. Heart attacks are the #1 cause of death in the United States. Although tobacco is the #1 preventable risk factor for premature death, don't smoke, you'll die. The death rates may be dropping for people who have support and health care. People may be living longer with heart disease and not dying from it. Your heart is a double pump. It consists of the heart, the circulatory system, and the blood. All of this meets at this organ that's maybe the size of a clenched fist. Your heart pumps about 5 quarts of blood every minute. Through the middle of the heart, we have tissue that's called the septum. It divides the heart into 2 halves. The chambers in the upper part of the heart are referred to as the atria, or the right atrium and the left atrium. The lower chambers of the heart are referred to as the ventricles. And we have valves that separate the chambers. The valves that lead from the atria to the ventricle are called the AV valves. And then the valves that take the heart from the ventricles to the rest of the body are called the semilunar valves. I don't know if you can hear my neighbor's truck backing down his driveway, but I'll just carry on. Capillaries are blood vessels that are specially designed for diffusion. They are tiny, tiny diameter blood vessels that basically connect arteries to veins, or in this case, the tiny diameter artery called the arteriole and the tiny diameter vein called the venule. The capillaries, in this case, we're looking at blood flowing away from the heart, oxygenated blood, going to, let's say, your left toe. So the blood that's flowing from the heart, oxygenated blood, is going to move into these smaller and smaller diameter vessels until it gets to your toe. And then it'll move through these capillaries with the oxygen diffusing out into the surrounding tissue. CO2 will then move into the capillary as deoxygenated blood, and the vein, the small diameter blood vessel called a venule, will then move the deoxygenated blood back to the heart. Coronary arteries are specially designed to transport oxygen and to and from the heart muscle itself. This 1 minute, 7-second video will review that with you. Please feel free to look at it. Don't worry about all the different names on either side of the heart. I've talked about what I want you to know. But from this slide, what I want you to understand is that the heart operates separately in terms of how it receives its oxygen and it gives up its CO2. What you see cushioning kind of the coronary blood vessels is fat tissue, but this isn't the type of fat tissue or fat that causes heart disease. It's the fat that's found inside these blood vessels, not surrounding the blood vessels, but inside the blood vessels that ultimately clog the heart and ultimately clog the blood vessels and can lead to heart attack. The heart generates its own impulse. The heart will beat independent of what's going on in the rest of the body. And that's because of this sinus node or SA node. There are cells in the right atrium that produce an electrical signal that spreads across the heart in waves. This electrical signal from the SA node moves to what's called the AV node, and then that spreads throughout the entire heart. What's unique about heart muscle tissue or cardiac muscle is that it contracts and relaxes as though it was one single tissue or one single cell. When you contract, say, your arm, different skeletal muscle tissue contracts at different time as you move your arm up and down. But your heart muscle, they all move at the same time. That's what's incredible about the heart muscle. One of the things you'll see in the video about the gentleman having the heart attack is that there will be a time when he appears to have survived his heart attack. Spoiler alert, the guy has a heart attack. But what happens is that for some reason, one of the cells in his heart decides to starts beating separately from the other cells in the heart. The narrator refers to this as electrical anarchy, because all of your cells in your heart, all of the tissues in the heart are supposed to relax and contract at the same time. This link will take you to a video that shows how a pacemaker works. A pacemaker replaces somebody whose SA node isn't working. The pacemaker will set the pace by which the heart is supposed to contract and relax.